right, ladies and gentlemen, good afternoon. This is Force of Motion Part 2. I just wanted to add some things to the last video that I did on Force of Motion. So we did talk a little bit about how if you have a force going in one direction and a force going in the other direction, then you would actually find the net force by subtracting them. But if you have, for example, an object and you have a force pulling in this direction at, let's say, a force of 15 newtons, but you have a force coming from this direction that is also pushing at the same time at a force of 10 newtons. In this cases, because both forces are going in the same direction, what you would do is you would add the forces. 15 plus 10 equals a total force of 25 newtons that is acting on this object. Okay? And let's extend it a little bit further. So what if we have an object and we have one force that's going in this direction and it is adding a force of 5 newtons, and you have another force in this direction that is also adding a force of 7 newtons, but you have a force that's pulling in this direction that's giving you, let's say, 10 newtons. Okay, well, you have 10 newtons going in the positive direction, and in this direction we're going to say -7 and -5 because they're going in the opposite direction. So we have -12 newtons plus 10 newtons gives me a total force of -2 newtons. What does -2 newtons mean? It means 2 newtons going to the left. Okay? So you always add up forces that are going in the same direction, and you subtract forces that are going in the opposite direction. Okay? And the force with the greatest, or the direction with the greatest force, is the direction that the net force will be moving in. Unless, of course, they add up to 0. Okay? So, I think in terms of what we're doing right now, you're pretty much just covering straight lines back and forth. But, just in case, I'll mention this really briefly. If you have a force that is, let's say this is 40, and this here is 40 as well. So we're going to say we have one force that is acting in this direction and one force that is acting in this direction on this ball. What is the net force and direction the ball is going to move in? Well, in order to do something like this, it's a little bit more complex. And like I said, I'm not 100% sure if you're doing something like this or if you will be doing something like this, but it is good to know. So the first thing you do is you mirror your forces, and you have to actually mirror them exactly. If you don't, you're going to get the wrong answer. So here, let's say, now if I did this correctly, then this length should be 40 as well, and it is just about there. Let me go from 60 to 20. And I am there. That is awesome. Okay, so now this is called a reflection. So I make my reflections with dotted lines so we could see the difference. Okay, so this is a reflection. So the reason we draw this line, let's say this is a force of 20 newtons here. Okay, and this is a force of 20 newtons. Or actually, we'll make it a little bit simpler. Since I did 40 centimeters, I'm going to do 40 newtons and 40 newtons. So we don't have to do any math. Okay? The net force, okay, would then be, in this particular case, it looks like, let me pick a different color. Hopefully this one works. Okay. The net force, well, this would be the balanced force in this case because of the direction it's going. But this is 56. So then it would have to follow this line and be 56 as well. Okay? So, to make it easier, now let's say it's not being hit this way and this way, but someone is kicking the ball this way at a force of 20 newtons in this direction and is kicking the ball this way at a force of 40 newtons, we changed it to 40. So if you're kicking it this way and you're kicking it this way, the net force would be 56 newtons. That is your net force. And your balanced force, nope, wrong one, is also 56 newtons this way. So what this means, if a third force, if one is kicking it this way and one is kicking it this way, and a third soccer player came and kicked it from this direction with a force of 56 newtons, that ball would not move. So this gives you a little bit more insight on balanced forces. Hopefully this made a little bit of sense. I'm not sure that you're up to this point, or you probably won't be until after midterms if you do this at all, but I know I wanted to cover this and this and give you a little bit of taste of what net and balanced forces are. If you have any questions, please feel free to send me a message. Again, I'm always willing to help, and I hope you guys have an awesome evening.